Hello, hello. So today we are talking about analyzing the spread of our data. So we have two parts of spread that we're going to be looking at today. The first is standard deviation, and we've talked about standard deviation before. It's part of our z-score formula, and we talked about it with mean-based measures of center. We talked about standard deviation goes with the mean. And then variance, we're going to learn today, goes along with standard deviation. So what does it mean to deviate from something? Take a minute to think about what does it mean to deviate. So some of you may have thought of deviating as like to swerve a little bit. To deviate, you go a little bit off the path or you go in the opposite direction. That's another way to deviate from something. Up here, to deviate means you like maybe miss the mark. You deviate from the goal or where you should be aiming. I like Benjamin Franklin's quote, "Don't be afraid to deviate from your schedule." Well, for our class and for statistics, to deviate means your distance from the mean. So in statistics, the deviation refers to a value's distance from the mean. So the standard deviation is the average distance from the mean for a data set. So deviate means to go away from the mean, or your distance from the mean. The standard deviation, think standard like the typical, the usual, the average, the standard. The standard deviation is the average distance from that mean. So I have two pictures down here. We can see a small standard deviation means very condensed data. A large standard deviation means a bigger spread of data. So when we say deviation, think about your distance from the mean. So how we calculate a deviation is it's your value minus the mean. We see it here, x minus the mean is just your data minus x bar, or the mean. So we use these deviations and we use this formula to find what's called the variance. So in your notes, for variance, I want you to make sure you get what's down in green. And what's in green says the variance is the average of all squared deviations of all observations from the mean. I know that that's super wordy, but I want you to get down that the variance is the squared standard deviation. So get down this notation, s squared, is the variance. That's my notation for the variance. It's s squared or sx squared is the variance. So our calculator gives us s, which means we can find s squared. So although this formula is given on the AP exam, we are not going to be using that formula to find the variance. We're going to be using our calculator or a standard deviation that's already given to us. So the standard deviation, just to review, is S, or we said it's Sx. And the formal definition for standard deviation is the square root of the variance. So the standard deviation is the square root of the variance, and it tells us, like we said earlier, the average distance from the mean. So if we think back to our picture that we saw, what does a large standard deviation and variance tell us? Well, it tells us that my data is very spread. A large standard deviation tells me my data is very spread out or very scattered. And we saw that with the pictures of the two types of standard deviations. So key point 1, standard deviation is the square root of the variance. So the variance is the standard deviation squared. Remember my notation, standard deviation is SX, the variance is SX squared, or just S squared. I can use the variance to find the standard deviation, or I can use the standard deviation to find the variance. So if we put this into practice and we see an actual example, it says, Miss Taylor wanted to know how many texts each student sends per day. She randomly sampled 5 students, recorded the number of texts they send a day. So if you get down anything from this example, get down the data set. It says, what is the sample standard deviation? Meaning, what is the standard deviation, or what is my SX for these 5 numbers? Well, if we think about ways to find it, do I have to use that giant formula? Do I want to plug all these numbers into that giant formula? No, my calculator can do it for me, and our calculator has actually been giving us the sample standard deviation, or SX, every time we do one var stats. So just to review, stat, edit, enter our 5 numbers, or any of the numbers, into L1, go to stat, over to calc, enter, we want to do one variable statistics on L1, and when I press enter, I see this screen. So you see we have 2 different notations for standard deviation. We've seen this sigma notation. Sigma is this little guy. So it's like an O with a little line. Sigma is the population standard deviation, and we'll get to that later. So for now, we don't care about sigma. What we care about is SX, or my sample standard deviation. So we want SX, and our calculator gives it to us in one var stats. So what was the sample standard deviation? SX equals, it said 8.4557. If we think about rounding, I just want you to at least round 2 decimal places. So this would be a very appropriate answer for the sample standard deviation. Part B says, what is the variance? Well, my notation for variance is the standard deviation squared, or SX squared. So all I do is I take my standard deviation and I square it. So 0.846 squared is my variance, which is 71.504. And for the sake of rounding, if you just round 2 decimal places, that would be okay too. So my variance is just my standard deviation squared, or 0.846 squared, and it gives me 71.50. So part C, just to review a little bit of z-scores, it says, what is the z-score for a student who texts 17 times a day? So 17 is my x value. If I think about my formula for z-score, x minus the mean divided by the standard deviation. So even though the problem didn't give me SX, or the mean, I found it doing one var stats. So since I found it already, I can use the numbers that I got from one var stats, and in one var stats my mean was 13, my standard deviation was, not 4, whoopsies, it was 8.46. So when I plug my numbers in, 17 minus 13 over 8.46, or 4 divided by 8.46, that gives me 0.4728, but z-scores we round to, so 0.47 is the z-score for a student who texts 17 times a day. So think about, could we have a standard deviation of 0? Could we have a standard deviation or a spread of 0? Take a minute to think about how could that happen. So suppose everyone texted exactly 10 times a day. So to have a spread of 0, that would be for all of my numbers to be the exact same. So if everyone texted exactly the same amount, if I did one var stats, I would end up with a standard deviation of 0. So that's key point 2. If all the values in a distribution are the same, then the standard deviation is 0 because there are no deviations from the mean. Everything is the same. Lastly, if we apply data transformations and what we've talked about with data transformations to standard deviation, so we've seen this before, this is review. It says suppose the average score on national tests or on a national test is 500 with a standard deviation of 100. If each score is increased by 25, how does the spread change? So think back to what we've talked about with adding a constant to a distribution. Well, if I add a constant, the spread does not change. The standard deviation stays the same. So this is review, but just to make sure we're really solid on it, adding a constant only impacts the center. Well, suppose the average score on a national test is 500 with a standard deviation of 100. If each score is increased by 25%, so increased by a percent, that would be multiplying each value by a constant b. So think back, how does multiplying by constant b affect the distribution and affect the spread? The standard deviation is also increased by b or multiplied by b. So if my standard deviation was 100 and I multiply it by 25% or by 1.25, I get 125 is my new standard deviation. So this is review, but just to make sure we're super solid. So that's a wrap. The standard deviation tells us the average deviation from the mean the values in an observation are, or the values in a distribution are. So this corresponds with section 2.2 in your textbook. That's where some of the homework for this chapter you'll see comes from. So section 2.2, make sure to check that out for extra examples and more practice. So until next time, have a great day.